The negative exponent rule. A base can change fraction locations from the numerator to the denominator or the denominator to the numerator by changing the exponent sign. If your exponent is negative in the numerator, then you can move it down to the denominator and have it be positive. If you have a negative exponent in the denominator, then you can move the base and the power to the numerator and change the sign. In our example, n to the fifth power, a to the third power, divided by n to the second power times a to the third power, we can rewrite this expression by bringing these denominator factors up into the numerator by changing the sign of the exponent. N to a positive 2 in the denominator becomes n to a negative 2 in the numerator. A to a positive 3 in the denominator becomes an a to the negative 3 in the numerator. Rearranging the multiplication so that similar bases are next to each other, we get the expression n to the fifth power times n to the negative 2 power times a to the third power times a to the negative third power. Using the product rule, n to the 5 minus 2 equals n to the third, and a to the third minus 3 equals 0. And that brings us to the next rule on the page, the zero exponent rule. Any base to the 0 power equals 1. So a to the 0 power becomes just a 1. N to the third times a to the 0 power becomes n to the third times 1. And that is just n to the third. Let's check for understanding. What is the result of using the negative exponent rule to move the base b to the numerator? How do you know? B to the negative 5 in the numerator or b to the positive 5 in the numerator? Blank is the result of using the negative exponent rule because b to the positive fifth power in the numerator is the result of using the negative exponent rule because the exponent sign must change. In the denominator, it was a negative 5, so when it changes to the numerator, this exponent goes from negative to positive.